Linear equations are equations in which you only have one variable, in this case x, being raised to the first power. When they're raised to a higher power, they take on different names. For example, a second power equation would be a quadratic equation. A third power equation would be a cubic equation. But this is a linear equation because this x is raised to the first power, and accordingly our equation will have one solution in the solution set. Now, if you want a step-by-step, blow-by-blow description on how to do this, go back to my introductory algebra videos. I'm going to be going through this rather quickly for these intermediate algebra videos. We want to isolate the x on the left, and we always undo addition and subtraction first. So we will be subtracting 8 on each side of the equation, using the subtraction property of equality on both sides of this equation. This leaves us with negative 3x on the left and 9 on the right. And then to isolate the x by itself, we want to undo the multiplication by negative 3. So we will divide off negative 3, and that will give us x by itself on the left is equal to negative 3. Now, a couple of comments here. Do not say, ooh, I need to get rid of the negative 3, because if you're thinking about getting rid of the negative 3, you might think the opposite of a negative 3 is a positive 3. We want to look at the operation that we are undoing. This is negative 3 times x, so we're undoing that operation of multiplication by dividing by negative 3. Second comment I want to make is that all equations are checkable. I can take this negative 3, substitute it into the original problem, and negative 3 times the negative 3 I'm substituting in plus 8 should equal 17. And what we're doing when we're testing this is technically we put a question mark over that equal sign because we want to determine whether that is a true statement. And on the left we have 9 plus 8, and we want to know, is that equal to 17? And in this case 17 is equal to 17, and this is a true statement. All equations are checkable by taking your solution and substituting it back into the original equation. Now let's just jump straight into a more challenging problem. When you have multi-step equations, the first thing you want to do is get rid of any grouping symbols, any parentheses. So do distribution first. So on the right I see distribution with that negative 5 and with the 2. So my next line becomes 13 plus 4w on the left equals negative 5 times negative 1 is positive 5w, and negative 5 times negative 6 is positive 30, followed by positive 2w and positive 2. So distribution is the first step. The second thing we want to do is combine like terms on each side of the equation. Now on the left side we don't have any like terms, but we do have two sets of like terms on the right, which I'm going to combine. So the left is going to remain 13 plus 4w, and the right side is going to become 7w plus 32. Now that each side is simplified, we want to get all the variables to one side, and you can either subtract 4w off of the left or 7w off of the right. Since most of you will prefer to have the variable on the left, I'm going to choose to subtract 7w on each side of the equation. So we're going to have 13 on the left minus 3w equals 32 on the right. Notice that what I'm writing in blue here is the actual equation itself, and in red I'm describing kind of what I'm doing to go from line to line to line. It's a good habit to get into showing your work as I'm doing here, and in general we list one step per line, so that if a person doesn't see the minus 7w on each side, they can say, ooh, something's changed, and it shouldn't be too hard to discover with only one thing being done per line what has actually been done per line. Okay, so we did our distribution, we did our combining like terms, we got all the variables to one side. Now usually we want to undo addition or subtraction to help isolate this w, and I'm going to begin by subtracting 13 from each side so that we can just have the minus 3w on the left by itself equal to 19 on the right. And then we will divide each side by -3 to get the w by itself, and w is going to equal -19 thirds. And that is our solution, and if we want to, we can take that -19 thirds and substitute it in for each of the w's up above, but most of you probably do not want to do that. One quick note about these fractions: do not use a mixed number. Okay, do not make this -6 1/3, because mixed numbers and algebra just don't go together. When it comes to how to write that negative, you could write that as -19 over the 3. You could keep the negative to the left, or you could write that as 19 over -3. Any one of these three means the same thing. Usually I put the negative up with the numerator, but this time I kind of did a halfway between the two. I just don't like my negative sign to blend in with that division bar as I'm writing these things out.